of traffic on this network, and that by knowing that straight away, you're aware that if you have a failure on the cross-connect between you and AS2, or you have a failure on that router on RT1, then suddenly you have to deal with 6 gigabits of traffic extra on your other router or via your other capacity that are normally not there. So you may well have a congestion or a quality issue. So straight away, as a part of this traffic engineering exercise, you see that you should look to negotiate a second private peering on a different cross-connect to your other router for this very important peer. If you've got another large amount of traffic flowing to AS1, can you configure a private peering, a second peering to this network via one of the exchange points that you're connected to, so that you prefer the private network interconnection that you have, you prefer the cross-connect, but in the event that the cross-connect fails, you're able to still deliver the traffic over the exchange if you have capacity there. Similarly, can you move some traffic from the larger exchange points onto private peering? So if you understand that you have another 2 ASs behind exchange points that you deliver a large amount of traffic to, can you move that traffic onto cross connects, so that in the event that you have a traffic failure on one of your other private peerings, there's capacity on the exchange point because you're managing the largest flows of your traffic. In the event of an exchange failure, where will traffic go? It may be that traffic how will traffic to the second exchange point and to the private 3 we have an understanding on our traffic grows, and we know that managing traffic engineering involves tricking the BGP best path selection algorithm. But how do we actually do it? Well, as I mentioned, this is an outbound heavy network with a single path that's originated by AS123, and I on this route by peering with AS300 to shape their inbound traffic via AS100. Is it here because the longer path is a lower capacity link, or is there a cost reason, or is it a more reliable link? What should you do? Well, the answer here is that it depends on the volume of traffic, the cost of capacity, and the value of the traffic to your business. If this is a large amount of traffic that you would otherwise deliver over an expensive link, and it's a very important flow of traffic for your business, then you need to make sure that that basically you're preferring the best link, the most effective link for this traffic, and that the backup path is reliable enough as well. You can do this. Here's a configuration example. Let me close this. There we go. Here's a configuration example that could be taken from a real network. It uses some real AS numbers in here, and I'm building access lists. I'm building access lists at 2 specific transit providers which I'm delivering traffic to, and I'm putting them in different ACLs, and then I'm attaching those ACLs to specific route maps on specific sessions with my peers, so that if I want to deliver traffic to, if I want to always deliver traffic to a particular network because it's the most cost effective, or it's the most reliable, or it's the highest capacity link, etc., I'm specifically putting those ASs onto an access list and attaching that access list to a route map that I can put on a BGP session to cause traffic to always go that way, or on a failure condition, always go another particular way. I'm not leaving it to chance. This is called deterministic routing. It means It means that you're in control of where traffic will flow in the event of a failure and a non-failure condition. If you're a mainly outbound network and you have exit routing, you're attempting to deliver traffic to this exit. You need to understand who your top traffic destinations are, and top traffic destinations at as many places as possible. So here's a slightly more complex example. I have a network that's in three different cities in Europe in this case, and you can see that I'm connected to different exchange points. Some out of two of these POPs, and it's a very, very similar exercise to the one that you run when you have a single POP, but you need to work out if you lose a whole point of presence and you start generating the content to send from another POP, do you have enough capacity to deliver the traffic there, or should you be negotiating extra private peering sessions or extra public peering sessions with particular networks who would give you a capacity problem in the event that you lose one of these POPs? And you use the same techniques, you use the same example that I showed on the previous slide to make sure that deterministic exits are followed. For your largest destinations, configure a specific preferred and a specific failover path so that traffic can be delivered in a predictable way. Another important thing to remember about deterministic routing, and another thing that configuring specific local prefs for your top destinations means, is that you can you're not leaving it to chance. You're not relying on the best path selection algorithm that may cause traffic to flow via some different means at awkward times of day or unusual times of day, or when you're not watching the network. You're configuring a hard exit. So if an exit is selected via local preference rather than for example someone else's MED, or maybe the oldest route in your routing table, the earliest learned route, your traffic will always flow in the way that you expect. But it does mean that if you have a route which is flapping up and down constantly, the traditional way of configuring this, where you leave it to the oldest route, means that you might start to flop your traffic onto a link and then another link and then the first and another link again. So what you have to do is make sure that you configure monitoring for the BGP sessions to your most important BGP sessions, so that in the event that you see links flapping, you can take action. You can down the link which seems to have the problem, causing your traffic not to flip-flop. That's the downside of using local preference to pick a specific exit. If the exit is flapping, you'll have a different problem. Inbound traffic engineering is a much harder problem, because the way that you influence the inbound flow of traffic to your network is to trick other people's best path selection algorithms. So you have to influence how other people are sending traffic to you. You don't actually administer the router that's sending you the traffic, so you can't configure local pref on the router sending traffic to you. You can only try and get that router to do what you want. But remember something I said at the beginning: the largest amount of traffic on your network is likely to come from a relatively small amount of ASNs. So you don't actually need to work out an inbound route to you from every network on the internet, just the ones that are sending you the largest flows, because by and large all of the other traffic that's not coming from maybe your top 10 or your top 20 or your top 30 can just come into your network through any means possible, because it's likely those flows will be much smaller and less of a problem if you have a capacity failure. There's something you can do, which you have to use it with care. So I'll detail exactly how this works in a moment. One thing you can do to cause best path selection algorithm not to actually matter when you're doing inbound traffic engineering is make selective announcements. So you maybe if you have a /16, announce it to peers as 2/17s, because the shortest prefix always wins over the best path selection algorithm. Now, it's very, very, very important that you follow certain rules if you're going to deaggregate, because deaggregation is generally considered a problem on the internet, and there's things you need to do to stop the spread of those deaggregated routes. You should note that peers often filter deaggregated routes so that they don't appear in your peers routing table, so you have to also send the covering aggregate. But also just deaggregating your prefixes, if you have a 16 and you deaggregate it to lots and lots of /24s, for example, that will be considered very, very rude and might lead to you being DP'd by your peers, because you could cause them an operational issue by deaggregating too far. And you should always, to try and keep the global routing table to as manageable a size as possible, make sure that those routes are not advertised globally. But selective announcements to specific peers can be used to great effect. So here in this example, in this example on the screen, we have a network that has a /8, one /9 in one city, another in a second city, and they announce the covering aggregate in both cities, but the more specific for that city only from the city where the traffic would ultimately end up. Now, again, there are specific rules. You should always add the no export community to your more specifics so that these prefixes won't end up in the global routing table. But you should also work with your peers to make sure that they find that this is an acceptable thing to do, otherwise you risk being DP'd for this action. Another way that an inbound network can influence traffic is through prepending their AS number into the AS path a number of times. This is because inbound traffic, sending networks, if they have the same local pref on all of your routes from two different exits on their network, they will simply pick the AS path which appears to be shorter. So if you make your AS path artificially long by putting your AS number in the path multiple times, then you'll find that inbound traffic will be sent to you via the AS path that you're sending the shortest path out from. Now, in my experience, this technique does have an effect, but it's an effect that degrades quickly. So if you put your AS number one extra time in the path, you'll find that that will have quite an effect. If you add it a second time, so that your AS number appears 3 times in the path, you're likely to find that the effect is reduced compared with the first time, and so on and so on. So if you're adding your AS number to the path 4, 5, 6 times, you'll find that that's likely to influence much less traffic than it was when you went from 2 to 3. It's normally used on inbound heavy networks where you're trying to signal which link is a backup link to the same AS. So if you connect your transit provider over 2 cross connects from 2 routers and you want to consider that one of them is the backup, you can send the same routes to the same transit provider multiple times, but on one of those paths with a longer AS path. And that will cause your transit provider to understand that this link is considered a backup link and this link is considered a primary link. Also, because your AS path prepending will only be seen, your peers will only take the best path from you. So if you're sending them a longer AS and a shorter AS at the same time, they'll take the shorter AS, which means that distant ASs may not see the prepending that you're trying to do. So again, this is quite a blunt tool, but it can be used very, very effectively to move some traffic if you're an inbound heavy network. A more finely grained way of handling AS path prepending is to use BGP communities to cause your transit provider to prepend only to certain exits. So, for example, here I found this was Deutsche Telekom. I picked at random their community rules. They're a transit provider in Germany, and they allow you to set communities to your routes as you send them to them, so that you cause your path to be prepended to their peers in some occasions. So, for example, if you want to influence your transit provider either not to send your prefixes to peers in one region, or to prepend only facing some peers or only facing some customers, you can ask your transit provider which communities you can set to cause that to take effect. Here we go. Here's the example. This example allows you to prepend a number of times to Deutsche Telekom's peers or their upstreams or their customers. So if you are finding you're having a capacity problem with maybe their peers or maybe their upstreams, you can prepend that announcement of your routes to their peers or their upstreams to cause less traffic to come in that way. And here you can say you specifically don't want the routes to be sent to their peers or their customers or their upstreams. And that's a much more finely grained way of controlling your traffic and making sure that if you find one particular exit is not very reliable, you can just not use it. If you're a inbound heavy network, you can signal to specific peers which entrance to your network you prefer using the MED attribute in BGP. So MED causes hot potato routing on the content network not to work if they honour it, so it's the opposite of hot potato. It means carry the traffic on your network to the most convenient entry point for me. It only works when you're sending the MED to the same peer in multiple locations or sending to the same peer with different MEDs. And it's the way that you typically use MEDs is to copy the IGP cost to the MED, so that if the IGP cost is high, i.e. the prefix is originated from a part of your network that's very distant, you attach a high cost to that route when you send the prefix via BGP. MEDs are normally subject to negotiation with your peers, and you shouldn't expect every peer to be willing to honour them. But your peers may honour MEDs if they are sending traffic to you which is very latency sensitive or loss sensitive. So, for example, if it's a VoIP company who your partner, you can say to them that you want the traffic to come in to at the closest point to the customer, so that they manage the quality of the service. There are specific times you can negotiate how inbound traffic is handled for specific cases where the traffic is very high value to both parties. You'll often find that your peers filter MEDs to a flat zero figure when they learn prefixes, so that their hot potato routing preferences override the MEDs. But sometimes they don't filter the MEDs, and sometimes you can negotiate that they will honour them from you in a specific case. Another thing you can do, normally again by negotiation, is change the origin attribute that's sent with your BGP prefix announcement, so that on your peers you send the origin with the highest priority, i.e. IGP, so your peers, if they see an equal AS path length and an equal local pref, then the best path selection algorithm will see what the origin value on the route is. And if you send your peers the origin attribute IGP, that means they are more likely to deliver traffic to you via that route than via your transit provider, which you're sending the lowest priority origin attribute to. On the slide is an example of how you configure that. You should give that a try in a maintenance window. I find that one works pretty well. Now, everything we've discussed so far about inbound traffic engineering has always said, I'll let Machuki look at this while I carry on. Everything that you've heard from me around inbound traffic engineering is that certain things sometimes work, and certain things work very well in specific cases. You're likely in the room to be wanting to know what works most effectively. How can I make sure that inbound traffic engineering works more time than it doesn't work? And the only way that works reliably is if you peer and make negotiations and make relationships with the networks that are sending you the largest amount of traffic. So you can use all of these techniques and all of these tricks to influence the way traffic comes to you, but the only cast iron way to guarantee that your inbound traffic engineering will come in on the link that you want with the right cost, the right quality, from the networks you want in an expected way, is to peer as widely as possible with your main inbound your main sending networks, and negotiate with them. Come to forums like this and say, this is what I'm achieving with my network today. This is what I plan to do in the coming months, in the coming weeks, so that they will. Because remember, the sending networks, the content networks that are trying to send traffic to you, also want the traffic to be delivered in the best quality. I think there's some more examples I'll need in a moment from the slides. Always patch your laptops as well. It's another important message. There are certain techniques you can use if a network says no to appearing, or puts specific rules around appearing, which I cover in the presentation in a moment. This is Machuki's flat. Slow. So we were talking about how inbound traffic engineering, the only way that you can reliably deal with these techniques. A lot of the technical methods you can use to try and influence traffic do work. But the most reliable information. If you understand how much traffic or how much traffic someone is sending you, you will stand out in the crowd. The peer will like to work with you because you'll know how much. You'll know that your data is accurate. He'll see you as a trusted source, someone that you can go to, or he can go to, who cares about the delivery of traffic as much as you do. And in a world where 100 of your competitors will approach your potential peer and say, hey, we'd like to peer, and won't have the data, won't have the understanding, won't have information about the volumes of traffic or the times of day, etc., you will stand out to a peer and be more likely to get the sessions that you want. And the other thing that managed relationships means is you need to protect your peers' interests. For example, discuss in advance mutual points of interconnection at a regular basis. Respond to any abuse complaints. So if your network is discovered to, if one of your customers is compromised or similar, respond to complaints about abuse very, very quickly, especially from your peers. And also use peering coordinators that you meet at forums like this to reach other peering coordinators who might not be at the forum, because it's a great way that your potential peers can help keep one of their relationships alive by introducing you as someone who is a good peer, who has the traffic, who manages abuse properly. And the other thing you must do, if you, from a relationship management point of view, is list your network on the Peering DB, which is a open database for peering coordinators to find each other and to list information about where they peer, which internet exchange points, which co-location facilities. It's unavoidable, unless you're a very, very small number of networks, it's unavoidable to not buy some transit as well. And traffic engineering, your transit provider choice matters when you are trying to traffic engineer in a smart way. If you buy your transit from a provider who is well peered, then it's likely that they are using some of these techniques to manage quality more effectively than they are playing games with your traffic. So buying from a well peered transit provider can improve quality for the reasons discussed previously, and also it can hide capacity problems from you automatically, because if you're buying transit from a badly peered network, their capacity issues will impact you, and if you're buying transit from a well peered network, their capacity issues will be managed and maybe hidden from you. Other things you might want to consider is if you identify that your top traffic destination is in fact a transit provider, it may well not be possible ever to peer with that network because of the different sizes of your network and them. And if your business relies on traffic quality, it may make sense to pick those guys as the traffic as your transit provider rather than a different network. And having data about how much traffic will stay on net for that transit provider or be sent to one of their other customers may help you get a better price. Because if you can approach a transit provider with cold hard facts and say, I'm delivering 50% of this traffic to your customers, you're going to be billing both sides. You can use that as a way normally to get the deal you need as well. If a potential peer that you want to work with for traffic engineering reasons does say no, there are some options. It doesn't have to be the end of the conversation. If the traffic is really, really, really important, if quality is really, really important for you and you don't think you'll ever get to turn the conversation into a yes, then you can consider paying for the peering session. The way this works is if your potential peer has a rule that says you must pay cities where you are, but paid peering is normally more expensive than full IP transit, and there's and Bill will have heard this sentence before many times. Once a customer, never a peer is a sentence that gets banded around by some of the larger transit providers who believe that if you've ever been a customer, you'll never ever be a peer. But paid peering is an option if the traffic really, really matters and you don't think you'll ever turn into a settlement-free peer. The other thing you can consider is seeing if the potential peer is open to peering with you if you agree to buy other services from them. So if you want to peer with a network who has a selective rather than a closed policy, you may find that if you buy transport services that you need from that particular company, you can negotiate a peering as part of that deal as well. But by far the most interesting and enjoyable way is customers, and then influence and importance to you goes away. Or even better, try and sell it to their downstream customers, because if you followed the advice in this presentation and have built a more well-peered network than their current provider, you can sell to these customers based on quality, which is a much more interesting way of dealing with the problem of someone not peering with you. Here's something that we're doing in the UK with where I work at Allegro Networks. We allow people to aggregate transit and peering capacity onto a single link, so that if they want to buy from 2 or 3 transit providers or maintain several peering sessions, the problem of what happens when transit providers or when a peering connection goes away on one link is also removed, because the traffic can stay on that physical interconnect. And you may find that in your market other aggregators of transit and peering capacity are available, or if you're in London, you may find that this is an interesting way of dealing with the problem of capacity sometimes going away when a transit provider has a problem or a peer has a problem, because other ways of dealing with the traffic are available on the same physical interconnect. So that might be another interesting way of dealing with the problem of capacity going away. But the main message in conclusion is that the way that your traffic delivered to your network or consumed from your network, capacity on the links that were adequate 2 years ago may well business needs today. Small networks become large, and large networks become larger rather than smaller in my from what I've seen. And a path that you may be depreferencing because of quality reasons may suddenly become good overnight. The problems may have been fixed, or when you sensed the issue it may have been a temporary issue. So you need to constantly monitor and manage performance of your peering networks. Now, I'd love to take any questions from anybody in the room. It would be really good if we had a conversation about traffic engineering. There's a microphone at the front. If you'd like a copy of the presentation, I'm sure it will be on the AFPIF site. You can also email me, and I'll send you a copy of the presentation by return as well if you prefer. But would love to open the floor to any questions.
I wanted. Yeah, okay, so one, you mentioned about inbound traffic engineering using smaller prefixes to advertise different transit providers. So we see that as being the most commonly used mechanism in Africa. People, particularly if they've got lease lines, SDM ones, they'll use that as a mechanism. The common mistake that we see happening is that they'll peer locally in their African internet exchange in their home city, but they will only keep the bigger prefixes on the local internet exchange. So their local peers send their traffic outside of the country, back to London, whatever, come back to Africa, making the latency much, much higher, because they make that common mistake.
Yeah, and that is a mistake rather than the technique isn't inherently bad per se, but you've got to be careful to make sure that, number one, that isn't happening. Number two, you're not polluting the global routing table from people who see you're covering aggregate and all of your more specifics just in the same way, and also making sure that you don't de-aggregate so far that your peers are upset. But you really do have, your point is perfectly accurate. You've got to make sure that you only send the more specifics to peers, and that you control the onward flow of those de-aggregates very, very carefully and use them with permission. Yes, absolutely. Single BGP table internally.
Hi there, this is Mike from Google. Just another comment on inbound traffic engineering. And if you're going to do that, talk to the peer before you do it, as Andy says, absolutely. Because as a content provider, we don't want you to do any inbound traffic engineering to us at all. We want all your prefixes everywhere, unless we've agreed something else with you, even if that makes your link to us completely full. And in general, having a completely full link that's kind of flatlined at 1 gig or something all day is a very bad thing and will cause bad performance. But when you're working with a content provider like maybe us or Akamai or so on, we can manage that, and we can make sure that even though the link is full, it's not causing bad performance for your customers, but we're just going to use it as effectively as possible. So when working with a kind of a non-standard peer like a content provider or a CDN, please talk to them before doing any traffic engineering, because anything you do could be making the situation worse for your customers.
Yeah, absolutely agree. The only way that works and works forever is working with your peers. You can apply some technical hacks around a particular problem one day, and you might be able to find a technique that works for a very, very long time. But working with your peers in the way that Mike suggests is exactly the way that it will carry on working forever.
I have a comment to add on that. So in a place where, adding on to what Mike's comment was, if you observe many exchange points, especially in Africa, most will peer through a route server. And that in itself has its advantages. The disadvantages for any peer who chooses to announce either longer, actually more aggregated, shorter prefixes versus what they announce on the internet, then the impact is actually larger. And just taking the comment from Google, I don't know how you end up working around that, where the announcements tend to be different from what they appear at the local IX versus what their global announcements look like, and where they're actually affecting a larger number of people at the IX, because it's difficult to play where it's not bilateral. Basically, the announcements are not being to Google only, it's affecting a whole group of people.
Yeah, the thing about root servers, I think, is that when you connect to an internet exchange point, it's normally a good idea to use the root server unless you know why you don't want to, because it means that if you have an open peering policy and you want to reach a large number of peers straight away, and there's no specific reason that's relative to your network, such as geographic reach and the complexities of traffic engineering on international networks, it's normally a good idea to connect to the root servers. But if your sessions to the root servers are misconfigured so that you're not taking advantage of the other exchange participants there, but that's a separate issue, I think, that if someone's made a mistake with their BGP config and is sending the wrong thing to the root servers and their peers, then that's something that is not specifically unique to root servers. It means that if they make bilateral sessions on the exchange, they will have likely the same mistake, because people may be using the same peer group for root server peerings as bilateral peerings maybe. So that's probably something that the internet exchange operator needs to look at. So if you're an internet exchange operator, and something that's a very important service that you should run is something called a collector, where you encourage people to make a BGP peering with the exchange operator's own AS, and then when you spot this mistake, periodically look at your new members' announcements, make sure that they're consistent with what they're sending to transit providers. If you see that people are making a mistake and they're not announcing all their prefixes, or they're announcing more specifics to their international transit but not their local peering, you need to go to the member and say, why are you doing this? Do you realise there's a mistake? I think that's the only way around that problem, is for the IX operator to run workshops or to get in touch with members who seem to be making a mistake, rather than to not use the root servers. Right.
Yeah. My question on that will be, how easy is it to you obviously to represent LONAP as well. Is there an automated way to monitor this? And because one of the problems, I think that goes into the comment from Ben Roberts, you will see this problem recurring. I work with the Kenyan Internet Exchange Points and a number of others in the region, and one consistent problem is that you send the announcements to the local IX will always be aggregated, and they'll send more specifics to their upstreams, and that becomes a problem. The exchange operator, however, unless somebody comes and complains, it's difficult unless the exchange operator is actually monitoring this consistently, or gets notified whenever there is a change between what they're announcing globally versus or to their upstream versus what they're announcing to the local IX. Are there any tools or features that you've come across that can actually be used to help the IXP operators to monitor this and...
I see.
Yeah.
Well, normally if people are making a mistake and it's one that causes traffic to go the wrong way, you'll see that traffic on the port falls. So you can monitor a lot of mistakes as an IXP operator by seeing if a member is suddenly sending you more traffic or suddenly sending you less. Now if they're suddenly sending you more traffic, that's great, because it could be that they've added a new customer or they've fixed a problem. But if the traffic has suddenly gone away, then that should mean investigation. And there's a tool on GitHub called IXP Manager that was again written by the Irish Exchange Point. It's an open source tool for managing internet exchange points, a portal that can be used, but it generates reports. So every Tuesday morning I get a report showing the ports which have the most increase or the most decrease of traffic, and if I see a member who suddenly has decreased their traffic and I don't know why, it doesn't seem to make sense, you can have a look into that. And that allows you to track all traffic impacting mistakes and not just specific mistakes, because really it's the traffic that matters. And if I see, and I won't look at them or point to anyone in the room, but I got a report saying, why is this member not doing any traffic on here, because they've been a member for 3 months? And they were in the room and I grabbed them at the break and said, you need to send me some more traffic. And it's a sort of report that gives you that data as well. So it's not just the ISP that needs data, but the IXP needs data as well. Okay.
Freddy Künstler, Init 7. To comment on this, we filter about 6,000 more specific prefixes out of our global table, because it makes that traffic is actually flowing the expensive path via transit and instead of flowing via peering. And all of a sudden traffic on transit jumps up again. We look at flow stats again. We use the tool you showed in the presentation, and then we set up manually new filters to avoid traffic flowing the expensive way. So this is basically what you can do. And I mean, if you're consistent with your own propagation or prefixes you propagate to transit and peers, you shouldn't see that. I mean, I think most networks here represented are inbound heavy networks, and this is what we see, the aggregation all over the place, but people just don't know how to manage their inbound traffic, and this is the impact.
If you do need to deaggregate, if you can test the effects of setting the no export community on your deaggregated prefixes, it means that your transit provider will see that and cause traffic to flow the way that the more specific would cause that to happen. But it means that the global routing table doesn't see it, so that Freddie's problem that he's trying to describe, i.e. traffic flowing via transit when it would likely benefit both parties if it went via a peer, doesn't happen as well. So if you do selectively announce, make sure that you limit the effect of how far that reaches, because the more distantly you're affecting, and an announcement in Africa causing something broken to happen in Switzerland, for example, that Freddie's just used is a situation that can be avoided by being much more careful with your selective announcement. So if you use them, you have to be careful. Okay, is that everything? Great, thank you very much again for having me. Thank you.
Okay, thank you very much. I'd like to invite our next presenter, who is Anibe Onuche. Anibe is with Internet Exchange Points of Nigeria, and he will present a presentation titled Benefit of AS Path Transparency Using BIRD. And this will sort of look at the AS path issues with respect to exchange points and using route servers. So, Anibe, you should be good to go.